Very good day, sir. My name is Justin MELING and GALAU. Today, we are from Group 5 going to present our project involving the torsional evaluation from actual structure. For the first part, introduction, note that torsion is important action that increase member shear strength. It occurs when it is twisted, causing twisting force acting on the member known as torque, and the resulting stress is known as shear force. In the field of solid mechanics, torsion is the twisting of an object due to an applied torque. Torsion is expressed in either the Pascal and SI unit for Newton per square meter or in pound per square inch, while the torque is expressed in Newton meters. In section perpendicular to the torque axis, the resultant shear stress in this section is perpendicular to the radius. In non-circular cross-section, twisting is accompanied by a distortion called warping, in which transverse sections do not remain plane. For this assignment, we plan to evaluate the tubular level lock set structure to the torsional loading. That's all for introduction. Thank you. Next part is objective. This assignment objective is to learn the basic theory of torsion theory and to find out the maximum value of shear strength, shear stress, and modulus of rigidity. Next is understanding the relationship degree of rotational and torque applied for the material under observation. Thirdly, able to understand the differences between material properties of variation type of material, therefore able to select material for different engineering components which under torsion. Last one is to determine the safety factors used in selected structure. That's all for objective. Thank you.
Hello guys, I'm Arunan Subramaniam. Today I'll be talking about the idealized model of our project, that is a tubular level lock. So based on the diagram, we can see on top of me, that is the tubular level lock, and the idealized model that I'm going to explain today. Okay, we can see that the length of the lever L1 is 160 mm and the radius of the lever is 12 mm, and the length of the lever from the lock set, that is L2, we tag it, is 45 mm. Besides that, we also can see that the force, we can see the arrow there, it is 80 Newton, is used to put the tubular level lock. Okay, then beside that, from this idealized model, we understand that the torque is equal to the force times the radius. Therefore, if the radius is greater, the amount of force required to turn the lever will be less, and the same concept will be applied to the bolt door itself and the position of the lever also. Okay, now guys, we'll see the free body diagram of the structure of the tubular level lock of structure. So this is the free body diagram that I've been researched with my friends. Then I have drawn this, so you can see that 80 Newton force we use, and this the M is the moment that we to open the level lock also. So this is our free body diagram. So that's all guys from me. Thank you very much.
Hi guys, I'm Nonason. Today I'll be explaining about the equations of equilibrium. Let's see the important formulas. First one, the allowable shear stress. Tau allow equal to Tc divided by J. T is the resultant internal torque. C is the outer radius of the shaft. J is the polar moment of inertia of the cross-sectional area. And the last one, tau allowable, is the shear stress allowable. Let's move to the second one. Maximum force that will fail the structure. F max equal to the T max divided by R. And the third one, factor of safety, FOS equal to tau fail over tau allow, or we can call it as shear stress of failure divided by allowable shear stress. Now let's move to the calculation. First of all, we need to find the applied torque. So the total sum of the moment is equal to 0. We can assume that the rotation anti-clockwise is positive. So negative TA, which is the applied torque, plus with the force and length, which is 0.16 meters times with the 18 Newton. So we can get TA, which is applied torque, which is 12.8 Newton meter. And then we can find the internal torque. Internal torque we can find by plus the applied torque plus with the torque at length 2. So as we can see the slide, 12.8 Newton meter plus with the 0.045 meter times 80 Newton, and we can get the TI or internal torque, which is 16.4 Newton. Okay, now we have to find the J. The value of J can be found by the equation pi r power of 4 divided by 2. So we got that J equal to 3.257 times with the 10 power of negative 8 m4, and then we can substitute the J, the value of J, to the allowable stress and find the tau allow, which is 4.715996 megapascal. We need to find the maximum stress. Maximum shear stress can be found by T tau max equal to Ti times the C divided by J. We already find the Ti, so we just need to substitute, and we got tau max equal to 6.042370 megapascal. And after that, we need to find the angle of twist. Angle of twist can be found by using the equation of Ta times the L1 divided by Jg. We got the angle of twist, which is 8.0615 times 10 to the power of negative 5 radian. So now we need to change the unit from radian to degree. So we got the answer 0.0046 degree. And after that, we need to find the maximum force. For the maximum force, we need to find the maximum torque first. So maximum torque equal to tau max times J divided by C. We got the torque max. Torque max is equal to 16.40 Newton meter. And after that, maximum force, we need to find the maximum force. So to finding the maximum force, we can use the equation of T max divided by R. So the force max that we got is 1366.667 Newton. And finally, we need to find the factor of safety, which is FOS equal to tau fail divided by tau allow, or we can also call it as shear stress or failure divided by allowable shear stress. So in this case, we got the factor of safety is equal to 1.281, which is more than 1. Thank you.
Assalamualaikum and very good morning. My name is Muhammad IQMAL bin Muhammad ADNIN, number metric B01911010. And now I will discuss about discussion. A torque is a measure of the force that can cause the object to rotate about an axis. Unlike the load which produces an average stress over the cross-section of the object, a torque will create the distribution stress over the cross-section. When the torque is applied to the structure, it will twist along with the long axis of the rod and the cross-section will remain circular. So the twist applied to the shear stress, we can expect that the torque will apply as the shear stress. The relationship between torque and shear stress was shown as the torque is equal to rho T over J. In this equation, J is the second polar moment of area of the cross-section and also referred as the second moment of inertia. To obtain the polar moment of inertia, J is depend on two types of shaft. First shaft is a solid shaft and the second is hollow shaft. By referring the formula of shear stress and shear strength, we use the Hooke's law to see how they relate. From there, we will get the formula of the angle of this, and the formula of angle of this is equal with TL over GL. where T is the internal torque in Newton meter, L is the length of the segment in meter, J is the polar moment of inertia meter power of 4, and G is the shear modulus in gigapascal. Factor of safety, or FOS, was the ratio of the structure absolute strength to actual applied load. This is a measure of reliability of the particular design. This is a calculated value and sometimes referred for the sake of clarity as a realized factor of safety. Factor of safety, also known as a constant required value that imposed by the law, standard, specification, contract or custom, to which a structure must conform or exceed. This can be referred to a design factor of safety, or required factor of safety. The formula of factor of safety is FOS is equal with top fail over top low. Since the factor of safety for this dog knot is more than 1, we can say that the dog knot are safe to be used. That's all. Thank you.
Hello guys, I'm back again, and thank you to my fellow friends that presented just now. Thank you very much guys. And now I'll be presenting again about the conclusion of our mini project. Okay, from this mini project that we conducted, the calculation of this assignment we done basically based on the learning outcome, which is to show how to calculate the elastic deformation of circular shaft subjected to torsional loading, and to show how to calculate the maximum power that can be transmitted by a shaft. Furthermore, we also learned the equation of torque, shear stress, and angle of twist. Last but not least, we were able to determine the relationship between applied load and force acting on the shaft. Okay guys, thank you, and that's all for me, and thank you to my fellow friends that presented just now. Thank you very much.